Good morning everyone, we are the students from FTKE UTEM. This is our video presentations for the subject MEKG 5143 Advanced Electrical Machines and Drives. The title of the lab test is Adjustment of Speed of BLDC Motor Using PWM Control Strategy. The lab test is conducted by me, Teo Ying, and my group members Chang Yang, Nurul Aimi Farjana binti Muhammad Jaidi, and Fatin Damia binti Nasruddin, together with our lecturer, Dr. Aljani bin Jidin.
Firstly, this is the hardware setup of adjustment speed BLDC motor using PWM control strategy. This is the power supply unit, BLDC motor, and BLDC motor controller. Okay, next we move to the hardware and software connection. Firstly, we connect positive and negative to the BLDC power supply. And then for the BLDC motor, we connect to the Hall sensor. Next, we adjust the voltage to minimum 10 volt. After we set the minimum voltage to 10 volt, we need to run the simulation in the software part. After the simulation had been run, we can see the rotation for this motor is rotate in the clockwise.
Once the hardware components are completely set up, we are going to build the software program to control the motor. For case 1, clockwise control on BLDC motor. First of all, we define PWM data in order to generate the signals to the relative switch to allow the current flow through the winding, so that the motor can be rotated in specified direction. Of course, we need to deploy the system block diagram corresponding to the hardware setup, installed in the controller. Then we can simulate the motor in real world and monitor the motor condition through the dashboard. When the simulation is started and the motor is supplied with enough power, we can see the motor rotate in clockwise direction. Hall sensor, IGBTs, and permanent magnets on rotor work interoperable to drive the motor in clockwise directions. We can also view clearly the current flow in armature part through the dashboard.
First of all, we need to adjust the y-axis limit for the current graph to an appropriate value such as 0.2. Next, we need to determine the location of Hall sensor signal HA, HB, and HC by looking at the end pole of magnet with 90 degrees. If the Hall sensor signal is located within the end pole of magnet with 90 degrees, the Hall sensor signals will be produced 1, otherwise it will be 0. So in this case, the Hall sensor signal HA, HB, HC will be 0, 1, 0. Next, we need to locate the north and south magnetic pole in the stator of phase A and phase C. So in the phase A plus and phase A minus, the phase A will act as the north magnetic pole in the stator, and the phase C plus phase C minus will act as the south magnetic pole in the stator, so that the rotor can be rotated in the clockwise directions. So the current comes from the voltage DC supplies, and it will flow through to the switch ones, and it will directly go through to the phase A plus. So the current is come in from the phase A plus. So in this part, the phase A plus have the cross directions to indicate the current is flows in, and the current is flow out from the phase A minus. So in this part, the phase A minus will have the dot directions. So in this case, these two directions will be the opposite from the A plus and the A minus, and then the current will continuously flows into the C minus. So in the C minus, they have the cross directions to indicate the current is come in, and the current is and the current is come out from the C+. So the C+ will have the dot directions to indicate the current is come out, and in these two directions will be the opposite directions from these two parts. And then the current will continuously flow through the switch 6 to complete the circuit. In this case, the switch 1 and the switch 6 must on, and the other switches must be off. So since the current is flow through phase A and phase C, the phase B there is no current to flow through. So for this part, the IB is in 0 ampere, while the current is flows into phase A. So in phase A, IA in blue color line is 0.2 ampere, and the current is flow in the opposite direction of the C. So the IC in orange color will be negative 0.2 ampere.
Next, for case 2, which is the implementation of adjustable speed drive of BLDC motor using TI Launchpad. Firstly, by adjust the voltage knob at power supply, the voltage value then is varies from 0 to maximum 22 volt to make the motor starts its rotation. From that, we can hear the different speed sound when we increase or we decrease the voltage. After that, we switch from hardware to software graphic user interface GUI by using dashboard similar to box for controlling motor speed. From the GUI, we adjust the duty ratio PWM to make the BLDC motor rotate. Lastly, we switch back the duty selector to hardware, and then we adjust the knob at BLDC motor controller to control the speed of BLDC motor. It can be seen that as we raise the speed, the motor will be increased too.